In this video, I want to have a look at ordered arrangements. So I want to start off looking at this problem that we're given. It says 8 friends go to the movies and sit next to each other in a row. How many different possible ways can this happen, or how many different ways can they be arranged? So we've got 8 seats in a row. Okay, so if we've got our 8 friends, that means that if we're looking to choose somebody to sit in this first seat, we have 8 choices. Because we've got 8 people, we've got 8 different people we could pick to sit in that first seat. For our second seat, we've already picked one person here, so that would leave us with 7 options for our second seat. Then because we've already picked 2, that means we've only got 6 left to choose from for the next one. And that pattern will continue. So this one we've got 5 options, this one we have 4, 3, 2, and this last seat we've only got one person left to pick from, so there's only one option there. So in one of our other lessons, we'll look at the multiplication counting principle, which says that if we want to find how many possibilities there are in total, we're going to multiply the number of possible outcomes at each step. So there were 8 possible outcomes there, 7 at the next one, 6, 5, 4, 3, 2, and 1. So we're going to multiply all of those numbers together. And if we do that, we'll have equal to 40,320. So there are 40,320 possible different arrangements of those 8 friends sitting next to each other in the movies. I want to introduce some new notation that's a bit of a shortcut for us. So in the problem that we just solved, we started with 8 people and we had to go 8 times 7 times 6 times 5 times 4 all the way down to 1. Now with a problem like that where we only had 8 people, that's not a huge problem. But if we had 100 people, you don't want to have to write out that whole multiplication from 100 times 99 times 98 all the way down to 1, because that's huge. So we introduce some new notation that makes that a little bit shorter. So what it's called is factorial notation. So what it looks like is an exclamation mark, and there'll be a button that looks something like this on your calculator. So x factorial means x times the number that's 1 less than x times the number that's 1 less than that, all the way down until you get to 1. So for example, if we had 6 factorial, we'd be going 6 times 5 times 4 times 3 times 2 times 1. If we had 12 factorial, we'd be going 12 times 11 times 10, all the way down to 1. So in the problem that we just had with the 8 friends in the movie theatre, instead of writing out that whole multiplication, we could have written 8 factorial is equal to 40,320. So our working out is a lot shorter. I want to have a look at one last example. So we've got 10 friends catch the bus to sport together. The back seat of that bus fits 6 people on it. And we want to know how many possible arrangements there are for those friends sitting on that back seat. So this time we've got 10 people, but we only have 6 seats. So if we think about that first seat, we're going to have 10 options for who can sit there. For the second seat, we'd have only 9 people left. Third seat, we'd have 8 people to choose from. Fourth seat, we'd have 7. Fifth seat, we'd have 6. And the last seat, the 6th seat, we'd only have 5 people left to pick from. So we've got those 1, 2, 3, 4, 5 seats picked. And if we multiply all of those together, we'd end up with 151,200 possible combinations for how those 10 friends can sit on those 6 seats. So this is sort of starting to look like a factorial, but we don't have that end bit on there. It stops at 5 instead of going all the way down to 1. So we can just write this out like this, and that's fine. If we wanted to use factorial notation though, it starts off looking a bit like 10 factorial, because that would be 10 times 9 all the way down to 1. Except that it's missing these last terms off the end here. So if we wanted to sort of cancel those out, because these are all times on the end here, we'd have to divide by 4 times 3 times 2 times 1. So that's the whole 10 factorial on the top. And if we look down the bottom here, 4 times 3 times 2 times 1, that's the same thing as 4 factorial. So we could write it as 10 factorial over 4 factorial, and that would give us the same answer of 151,200. So that's a few examples of ordered arrangements.